So without further ado, it's my pleasure to introduce Pierre Millet, who's the domain solution architect at Microsoft Industry Solutions. He lives in wonderful Madrid in gorgeous Spain, so he enjoys the good time. Pierre Millet, buenas tardes, and the floor is yours.
Buenas tardes, good afternoon, and good morning for the Americans. So let me share my screen. Yeah, so should I share my screen? Sorry. Okay, could you see it?
Yeah, Pierre, we good?
Yes. Okay. So let me present you the ASISA case. So this is a project that we did for ASISA, a health insurance company in Spain. And this company, what we did was to modernize, so to migrate one of their legacy business critical application workloads to Azure. So what we did really is very similar to what Uli was explaining at the beginning. So we moved the legacy application into a cloud native, fully cloud native environment, running on Kubernetes, and also using DevOps for all the continuous integration and continuous deployment processes. So during this presentation, I will talk to you about the strategy, how it was the strategy that we follow, and the decision that we take for that. And also we will talk about the solution architecture. And then I will show you a quick demo about how the full end-to-end process, so you can see how from COBOL code until we get deployed into a container apps. In that, actually, we have a sample that also show how to move COBOL into a container apps. So this slide it's funny. I like it because it shows the evolution of the mainframe, no, since the 60 or 70 until today. So we have there is many stages, no, around the way, and this spaceship that you see is our solution. So this represents our solutions, and what we are able to do is to take. Inside our spaceship, we will take a jewel, diamond, that is your more valuable asset, that is your COBOL code, and we'll bring it into a cloud native environment. So we are going to travel 50 plus years of history in a moment. No? So this is just to make reference to Star Wars movies. And then here it's a representation of the different, let's say, strategies that you can follow. No? And from in the bottom left is the no strategy. So that it means you do nothing. You stay on the mainframe with your COBOL code and your DB2 into your monolith. The second option that you have is to expose some of your transaction to the outside world through APIs, through REST APIs. So this is something that you can do. IBM has also a solution to convert some COBOL programs and publish REST JSON modern open APIs. And this is exactly the situation that we found when we started this project in ASISA. ASISA already did this step, so they already was publishing their mainframe application through an API, but the application is still running on the mainframe. So the second option that you have is take the code as is, lift and shift, compile it, and put it all together into a container app, into a container solution altogether, and with a single database. And the next strategy is the one that we follow. It's what we call the transform strategy, is that we take this COBOL, but we decompose it. We decompose if of the business transaction is independent transaction. And then also we are able to create new transactions or new microservices aside in C#, in Java, in whatever language we like. And thanks to this Dapper solution, we are able to interop with our COBOL legacy application and their new technology stacks development. So we really, in the transform stage, what we really have is a complete homogeneous solution where COBOL developers and C# developers and Java developers can work together using the same patterns and practices. Then we have the last is the revision. The revision is what we call a total rewrite. So you start from scratch and you rewrite everything so that you can rewrite in any language. So what we recommend is the transform, since it's a fast track to cloud native. So the main milestone that we follow at ASISA was we started with a high-level assessment of the code just to quickly have a grasp on the complexity of the solution that we were trying to sell this project. Then we did a technological POC just to demonstrate that the technology was doing what was expected to do. So we took one transaction, we migrated to .NET, and we were able to execute it. Actually, we executed in as ASP.NET application or as a function. So we were able to show the customer that this technology was okay. And then once the customer was okay and was confident about what we were able to do, we started the migration of one of their workloads. So the goal here is not to migrate the full mainframe, is to start with one workload that we identified as a workload that was not too small, not too big, and that represented like a 20% of the mainframe. And this workload is called Professionales. And we did all during this project, let's say, piloting of this Professionales, we deployed infrastructure in Azure, in the Kubernetes. We also set up all the DevOps pipelines and DevOps infrastructure, and we migrate the code and we deploy it into production. So since September 2021, this system is in production without any issues. And now we are starting the second part that will do the full migration. So the idea is, by doing this MVP, is to get the muscle and the practice about how to do it. And then with this knowledge, we are able to do the full scale migration more quickly. So this is an iterative process and very agile mindset. So here is let's say the conceptual architecture. So we have in blue is the legacy and the green is the new things. So we have a user interface that we don't touch. So one of the goal was don't touch the UI. The UI is still connecting to the WAS, the WebSphere application server. And then we have a request dispatcher, very similar to what Pierre was explaining, where we can redirect the calls to the previous IBM IP gateway or to the new Azure API management. So what we did is create an API that was totally conforming to the IBM API gateway. So that in that way, all the calls from the UI work also in the new system. So we're able to execute the same transaction against both systems. And this was done like it's what we call a dark deployment, a dark launch deployment. So we execute in production, we execute the green line, and then in the background we re-execute the request, and we keep all the response that we receive from the legacy and the new system, so that after that we can examine or analyze the response and looking for difference. And if we spot a difference, then we can troubleshoot it, try to see where is the difference and why there is a behavior that is not the same. We also, during this project, we also moved to DB2 and SQL Server, and also we use a change data capture solution so that the data was replicated in near real time. Okay, so this is the final reference architecture. There is a part in the left, in the right, in the left bottom side is the DevOps, all the DevOps logic. So you have a unique user interface, IDE, sorry. And then we move the online application into Kubernetes, and we also migrate the batch, and we also have some routes to the on-premise backend, just for the data, copying data and moving data from the on-premise to the batch. And so this is under the cover. We use Dapper, Keda, Prometheus for the metrics, so on. So this is a little bit a summary of the decision that we took. So first, we preserve the COBOL code for online and batch. We don't touch the COBOL. So this is the COBOL still COBOL, but running into a modern user development environment like Visual Studio, and with all the tools that Visual Studio has, like debugging, so on. This COBOL code is shared between the two systems. So we deploy the same code in the mainframe and in the new cloud native system, so that if there is some difference, so we don't never diverge. No, so this is very important. We also respect the existing ABM API schema, so that in order that we don't have to change the user interface. In the user interface is using exactly the same API contract it was using from the beginning. We deployed all this solution on an existing Azure and DevOps environment that the customer already invested some years ago. So also we have the chance that they already have made some investment there, and they were already using this, so they already have some kind of knowledge about DevOps and Azure and so on. So this was also a good thing. And we reduced the infrastructure, so they didn't have to invest more. So they just maximized their current investment. We also adopted a cloud native and development practices for agility and innovation. So this it's also one of the goals, is to reduce the IT skill gap between COBOL developers and C# developers. So when we did the project, one important part of this project was also the transfer knowledge, to the COBOL developers. Now they are going to start working in a new environment they are not used to, and they are going to start making commits, push, tests, and things like that. But they will still develop in COBOL. They will still maintain their COBOL application in COBOL, although they can create new application or new functions or new programs in other language, because now everything is .NET, everything is cloud native. The process of migration also has been, it's a quick and industrialized code migration process. So since we don't touch the code, the code is automatically migrated, and also is automatically deployed into target environment. This is something that I will show you in the demo. And then also we move the data to SQL Azure just for performance, since the SQL Azure is running side by side near the cloud native environment. So also we allowed some architecture improvements, so that to make that the database was so near to the runtime, the cloud native, the Kubernetes environment, so that the latency was minimal. Also, we have it's obvious, also a cost reduction, and also we are able to unlock some business intelligence. Since we have the SQL Azure, we can take advantage of all the good tools that we have for that. And then from a deployment and testing strategy, as I mentioned, we did the dark launch, that is recreating the request from on-premise. So during a time, this is a phased approach, so that there is a time both systems are running side by side. And then also we can do like a blue-green. Blue-green means that we can switch back to the mainframe or switch to the new system in case of fallback or any problem. So this was the main, I think, more important decision from a strategic point of view. And at the end, what we were able is to roll out to production. So this took like eight months of work. This was very important because we did this with a small, agile, cross-disciplinary team with people from ASISA, from Microsoft Industry Solution, and Raincode. And it's very important to create these synergies between the customer, the tool vendor, in this case Raincode, and we were acting as Microsoft as integrators, and also the one who knows about the cloud native and Azure. So now ASISA is in the position to quickly deliver new business capabilities in the form of new microservices, and also he can leverage and extend their existing legacy business capabilities. And this is the sentence when we finish the project, when we put it in production from the CTO. And he told us the rollout to production has been a success. We only suffered the typical delays and some minor incidents, and the performance is even better than expected. And this is true because the performance, since now we have this auto-scaling capability, this is a big change from what they have previously. So I will ask Alex to launch the demo recording I made this morning with a sample that will show you the end-to-end. So go ahead, please. I don't know if I exceeded my time or not. In this demo, I want to show you a full end-to-end process to develop a COBOL application and then publish it as a API ASP.NET Web application into a container apps. So the process, the end-to-end process starts with the coding. So we make modifications into our code files. We push these changes into our repository. From there, the files are compiled using the Raincode agent compiler that will produce assemblies that will be packaged into NuGet objects and deployed into the DevOps artifacts repository, where we have all the different artifacts. In a second step, we take this code and analyze it and generate code to generate a ASP.NET Web API REST API for this COBOL application. So we are able to understand how the COBOL is built and automatically generate a specific schema, API schema to be able to invoke this COBOL application from the outside. Then we take this ASP.NET Web API generated code and we publish it as a container into Azure Container Registry. And from there, we are able to deploy it to the container apps environment using infrastructure as code scripts. And then once deployed, we can test it and see if it's behaving as expected. So let's go to the next slide is just to illustrate all the steps. So the COBOL sources, then the compilation to the Raincode agent, the generation of the artifacts, the API generator that also generates a new branch into the checking accounts of API. That then we merge with the main and we generate the Docker image and then publish into the container apps solution. So let's go to the code and see the process end to end. So here I have a COBOL application that is called getBalance. I also have a .NET C# application that it's a test application that invokes this COBOL application. So if I execute this, you can see also that the developer experience, we will have the same developer experience in COBOL that in C#. Actually, we can execute from COBOL to C# in the same session. And we can do whatever we usually do in the debugging session, step-by-step execution or looking for the value of the variables. If I continue, then I come back to the C# application that call it and can see the result of the execution. Here, the account ID 1 has a balance of 200. So my application, it's already deployed in Azure. So, for example, here I can. So I go to the Container Apps application. I click here to the link. This will drive me to the user interface of the API that I just deployed. We have a create account, delete, deposit, get balance, get holder. So different options. And now what we want to do is add a new method here. So for doing that, we are going to come back to the COBOL application. And we are just adding a new program. a new COBOL program that we will call Say Hello. It's a very simple transaction, COBOL Kicks transaction, that I will copy from a snippet. And now I want to make this Hey Say Hello also available into my web API. So once I saved, what I will do is execute my code generator application that will analyze the code and will do all the steps necessary to compile this code in my local machine, and then submit the code into the repository and trigger all the pipeline, the code generation pipeline. So here we are. So now what we can do is take a look to our pipelines to see if a new pipeline has been triggered. So this pipeline is the one out, is auto-generated code. This pipeline will generate two packages, one for targeted to with the same code, but one targeting DB2 and the other targeting SQL Server. So we can use the same different versions of the code depending on the target database. So when this finishes, it will create a new version in our NuGet repository of the last that will contain the just added Say Hello solution. At the same time, the code generator also has made a new branch for our with the web API. So if I go to the web API solution, I go to my Git repository, I will see a branch has been generated. So what I can do is merge this branch into the current branch, that is the main branch, so that I can take the changes in my main. In this case, since I added a Say Hello, I should see a new Say Hello controller appear. So this is the new controller that will allow us to invoke the COBOL code. And then also there is some code that has been auto-generated in the Say Hello folder, where we have all the logic that do all the handling and transformation of the JSON payload into a COM area and memory, and also do the integration with the runtime, the Raincoat COBOL runtime. So once we have the code merged, we just need to update our package, our NuGet package, and for that we are going to look for the Raincoat package source and looking for changes. Once the compilation, the package compilation has finished, that is still ongoing. So we will stop the recording 1 second here and retake it when it finishes and continue. So here we are again. Our job has finished, so a new package should be available. So let's go to the web API, refresh to see if there is another package, and take the latest one, the version. So we update our web API solution. We accept. Okay, and then here what we can do is now save the changes and commit and push. So update it. Commit and push. So this will generate the ASP.NET Web API image into a container apps, into a container solution. And in this first stage, and in the second stage, it will deploy it to the container apps infrastructure in Azure using infrastructure as code. In this case, it's a Bicep technology. and then once it's finished, we can take a look and test if the application is well deployed and working as expected. So now that our application has been generated and deployed into the Kubernetes and to the Azure Container Apps environment, we will see here. I can refresh. We can see in the revision management if it's been published, correctly provisioned, as you can see here. And then let's again navigate into the Swagger and let's see if our new say hello transaction is available. As you can see, it's there. You can try out, execute it, and check and test it's working as expected. As expected, we receive a response with the message, "Hello, folks." So this is the demo. We have also just added notes as side notes that we have also application insights, all the application insights functionality, so we can look at all the traces generated by this application. So for example, let's look for the last 30-minute request. And for all the traces, as you can see, we have different information here available. We also have an application map so that we can see all the instances. So for example, for the last 30 days, we can see all the things that have been happening in the solution. We also many applications, so have all the information available here. And then other scenarios or demos that are not covered here, but one of them is this one is calling between inside the same application environment, checking account API COBOL application being able to call a Java application that represents, for example, the customer's microservice. And all of this is done transparently using the Dapper runtime that is part of the Container App solution. And we have the log analytics application insights functionality out of the box. And this is the batch runner. The batch runner is also something that we have in this in the demo. It's a container that is running on where we are running the GCL runner, and we are able also to dispatch jobs that are executed inside this runner image. And all these images are mapped to files that are mounted in Azure file volumes and so on. But this is for another demo. Thank you for your time.